The strongest storm on Earth right now did not start as a storm at all. It is not a hurricane forming in the Atlantic. It is not a system anyone in Florida or the Caribbean needs to worry about. It began as a patch of disorganized thunderstorms drifting west over the Pacific Ocean, so unremarkable that almost nobody outside a handful of meteorologists in Hawaii even knew it existed. And in less than 48 hours, it became one of the most powerful tropical cyclones the planet has produced all year, with its eye locked on American soil. Today, we are breaking down everything. What Bavi actually was, how fast it intensified, what scientists were saying about it in real time, what happened when it made landfall, and what it left behind as it kept moving across Asia. No filler, no guessing, just the facts and the full picture of what happened and what is still happening. If you want updates every time a storm like this develops, make sure you are subscribed and notifications are on. You do not want to miss real-time coverage on something this serious. A thumbs up also tells the system to show this to more people who need the information. Now, let us go. This is the story of Super Typhoon Bavi, what scientists said as they watched it explode in strength in real time, and what it means for the islands and coastlines still standing in its path. To understand why meteorologists were so alarmed, you have to go back just a few months earlier to a storm called Sinlaku. In mid-April 2026, Super Typhoon Sinlaku tore through the U.S. Northern Mariana Islands and Guam with sustained winds up to 185 miles per hour, a storm surge of 10 to 15 feet, and a central pressure that bottomed out near 905 millibars, low enough to make it, at the time, the strongest tropical cyclone recorded anywhere on Earth in 2026. Sinlaku killed 17 people and caused roughly $1.5 billion in damage across the Northern Marianas and Guam, according to meteorologist Jeff Masters writing for Yale Climate Connections. It knocked out power across large portions of Tinian and Saipan, damaged homes, flooded roads, and left communities that were still, months later, working to rebuild. That is the baseline. That is what the region was already dealing with when the next system started organizing at the end of June. On June 25th, the Joint Typhoon Warning Center in Hawaii flagged a low-pressure area forming roughly 900 nautical miles east-southeast of Kwajalein. Satellite imagery showed it was sitting in an environment favorable for development, but at that stage it was nothing more than a disturbance, one of dozens the JTWC tracks across the Pacific in a given month. 4 days later, the agency issued a formal tropical cyclone formation alert. On July 1st, it was upgraded to a tropical depression designated 09W. By midday July the 2nd, the Japan Meteorological Agency had named it Bavi, a name contributed by Vietnam, referring to the Ba Vi mountain range. At that point, Bavi was a modest system with sustained winds of just 60 miles an hour. Almost nobody outside the meteorology community was paying attention to it yet. Then came the acceleration that made scientists sit up. According to the JTWC's own advisories, Bavi's 1-minute sustained winds jumped from about 80 miles an hour to roughly 145 miles an hour in only 18 hours, a jump that took it from a tropical storm to a Category 4 equivalent typhoon in less time than most people spend at work in a single day. Meteorologists Jeff Masters and Bob Henson, writing for Yale Climate Connections, described a storm that appeared poised to become a dangerous Category 4 or Category 5 super typhoon within 24 hours of its very first advisories, and noted that this was already the 4th typhoon of the year, forming as the region moved deeper into what they called the most active months of a long 2026 Western Pacific typhoon season. By July 4th, Bavi had reached Category 5 equivalent status, with the JTWC reporting maximum sustained winds near 166 miles per hour, gusts up to 200 miles per hour, and a central pressure near 919 millibars. Some forecast models were showing the possibility of the storm topping 180 miles per hour before it reached land. Hurricane specialist Michael Lowry reported that roughly 60% of Google DeepMind's machine learning-based ensemble forecasting system was projecting Bavi's intensity to exceed 180 miles per hour, and wrote plainly that this would rival Sinlaku as the strongest storm globally so far in 2026, with the potential to be stronger than either Sinlaku in April or Typhoon Mawar, which struck Guam in 2023 as the most powerful storm to hit the island since Super Typhoon Pongsona in 2002. Atmospheric scientist Marshall Shepard, writing for Forbes, laid out exactly what was fueling this in language that strips away the mystery and gets straight to the physics. The JTWC itself described what its satellite imagery was showing in stark terms, reporting that the storm's eye had cleared out completely and that gale force winds extended nearly 200 nautical miles outward from the center. Unfortunately, the agency wrote, atmospheric and ocean conditions were highly favorable for further intensification. Shepard translated what that actually meant in practical terms. High ocean heat content, low vertical wind shear, sufficient atmospheric moisture, Textbook. Outflow at the upper level of the storm. Every single ingredient a tropical cyclone needs to strengthen rapidly was present at the same time, in the same place, and forecasters had high confidence in both the storm's track and its intensity over the following 3 days. Shepard also made a point of reminding his audience that Bavi was already the third storm to reach Category 5 equivalent intensity somewhere on Earth in 2026, following Tropical Cyclone Horatio in the southern Indian Ocean back in February and Sinlaku in April, a pattern that was becoming difficult to describe as unusual when it kept repeating itself. There's a specific atmospheric process behind why storms like Bavi are forming the way they are this year, and it goes back to something scientists have been watching build for months. Jeff Masters noted in his Yale Climate Connections coverage that Bavi is exactly the kind of storm meteorologists expect to see forming when a strong El Niño event is developing, which was the case through the middle of 2026. During El Niño years, typhoons in the western Pacific tend to form farther east than usual, which sounds like a small detail but has an enormous effect on storm intensity. A typhoon that forms farther east spends more time crossing open, undisturbed ocean before it curves north and west toward land, and every extra day spent over warm water is another day of fuel available to intensify. Masters explained that this dynamic gives storms forming in El Niño years a meaningfully greater chance of reaching Category 5 intensity before they ever threaten a coastline. Sea surface temperatures across the region Bavi was crossing were measured between 84 and 86 degrees Fahrenheit, roughly 29 to 30 degrees Celsius, well above the threshold. Tropical cyclones need to maintain themselves, let alone intensify explosively. Wind shear across the same region was measured at just 5 to 10 knots, low enough to leave a developing storm almost entirely undisturbed, as its internal structure organized around a tightening eye. This is the part where the science stops being abstract and starts being about people, because as Bavi intensified, it was doing so on a direct path toward the same islands Sinlaku had devastated less than 3 months earlier. As of the storm's approach, roughly 2.5 months after Sinlaku made landfall, parts of Tinian and Saipan were still without full electricity. Emergency shelters that had been used during Sinlaku were still standing, some homes still covered with tarps instead of repaired roofs, infrastructure still compromised from the earlier storm, and now a second Category 5. Equivalent system, potentially stronger than the first, was bearing down on the exact same small population of islands. Forecast models disagreed on exactly which islands would take the worst of it. The American GFS model tracked Bavi's center directly over Tinian and Saipan, the same communities Sinlaku had already devastated. The European ECMWF model placed the center further south, closer to Rota and Guam. Emergency managers across all 4 islands had to prepare for both scenarios simultaneously, because the difference between them was the difference between a catastrophic direct hit and a severely damaging but survivable event, and there was no way to know for certain until the storm arrived. An emergency official in Guam told reporters that the territory had many vulnerable communities across northern Guam, people living in substandard building materials, and that based on what he had heard from Saipan and Tinian, the situation there was dire. The National Weather Service used blunt, unambiguous language in its advisories, describing what was coming as an extremely dangerous and life-threatening situation. A government official in Guam summarized the mood plainly. "We aim for 0 fatalities," he said. And my gosh, I hope that is how it turns out. It is going to be a rough night and a rough day. What actually happened, when Bavi's eye finally arrived, was that it passed directly over Rota, the southernmost island of the northern Mariana chain, home to roughly 2,000 people, on the morning of July 6th, local time. Winds on Rota exceeded 150 miles an hour as the eye moved overhead, and local reporting described the resulting damage as catastrophic, though full assessment was delayed for days because communications on the island were severely disrupted. Guam, sitting roughly 50 miles southwest of Rota, recorded maximum sustained wind gusts of 111 miles an hour and set a new daily rainfall record at its international airport, over 12.5 inches of rain in a single day. Saipan also recorded gusts of 111 miles an hour. NASA's Earth Observatory later published satellite imagery from the Xi-Ars instrument aboard the NOAA-20 satellite, capturing Bavi's eye near Rota in the middle of the night, moonlight from a waning gibbous illuminating the western eye wall just hours before landfall, with winds at that moment measured near 180 miles per hour. Despite all of that, despite a Category 5 equivalent storm delivering a direct eye wall passage over a small, still recovering island, no deaths were confirmed on Guam or the Northern Mariana Islands. Damage was extensive. A water distribution station on Rota was damaged. Power poles and lines were downed across the region. Roads were flooded and littered with debris. The Coast Guard worked for days afterward to clear navigational hazards and reopen ports around Guam and the northern Marianas. But the outcome that scientists and emergency officials alike pointed to afterward was that early, aggressive, honest communication, evacuation orders issued days in advance, and shelters that filled to capacity before the worst of the wind ever arrived kept a storm capable of mass casualties from producing any at all on American soil. Bobby did not stop at the Marianas. After passing Rota, it continued moving west-northwest at roughly 9 miles an hour into the Philippine Sea, still carrying sustained winds well over 150 miles an hour, sustained by the same warm open water that had fueled its rapid intensification days earlier. NASA's Earth Observatory noted that by July 8th, as the storm moved across the Philippine Sea, the National Weather Service was reporting maximum sustained winds of 155 miles per hour. Still a powerful typhoon, even after days over open water. Forecasters expected the track to bend northwest toward Taiwan, the Ryukyu Islands of southern Japan, and eventually mainland China, gradually weakening as it encountered cooler water and increasing wind shear, but remaining a serious threat the entire way. Known in the Philippines as Super Typhoon Inday, Bobby's outer bands and the broader monsoon pattern it enhanced, locally referred to as the habagat, brought punishing rainfall across the southern Philippines. By July 12th, the National Disaster Risk Reduction and Management Council was reporting 17 deaths and more than 514,000 people affected by the combined rainfall and flooding tied to Inday and the habagat monsoon surge. Separate reporting from the Philippine News Agency and the Philippine Daily Inquirer described rainfall-triggered landslides that killed at least 10 people in a village in Sarangani and 7 more in a town in Lanao del Sur, which was subsequently placed under a state of calamity. As Bobby's remnants tracked toward Taiwan, authorities there took the storm seriously well before it arrived. At Fugong Fishing Harbor in Taitung, boat owners hired cranes to lift inflatable fishing rafts out of the water entirely, a precaution taken after previous typhoons caused moored vessels to collide with each other in the harbor. Guishan Island was closed to tourists preemptively from July 9th through the 12th. Taiwan's Highway Bureau placed the Suhua and Beiyi highways and the Northern Cross Island Highway under close monitoring for landslide risk, and officials warned that the newly opened Danjiang Bridge could face speed restrictions or a full closure if sustained winds crossed certain thresholds, with forecasts calling for gusts up to 149 kilometers per hour and as much as 16 inches of accumulated rainfall in mountainous areas. By July 12th, local Taiwanese reporting tallied 87 injuries, more than 1,450 separate disaster reports, over 1,600 people evacuated into shelters, and more than 700 fallen trees across the island as a direct result of the storm's passage. In Japan, fire and disaster management authorities were compiling their own damage reports from the same system as it brushed the southern islands on its way toward the East China Sea. Zoom out, and the pattern that scientists were describing throughout Baby's life cycle is bigger than any single storm. Marshall Shepard made a point, when discussing Bobby, of reminding people that American audiences tend to be Atlantic-centric in how they think about hurricane season, checking the news for storms near Florida or the Gulf Coast, while a much more active and far more dangerous basin churns on the other side of the world almost entirely unnoticed. The Western Pacific is, and has consistently been, the most active tropical cyclone basin on the planet, producing more storms and higher peak intensities than anywhere else on Earth. The 2026 season had already produced multiple Category 5 equivalent systems, before its climatological peak in August through October. Weather News, in its own seasonal outlook, projected an above-normal season for the Northwest Pacific, citing a developing El Niño with the potential to rank among the strongest on record as the dominant driver shaping where and how intensely storms would form. Through late May, 6 typhoons had already formed, roughly 3 more than the normal pace for that point in the year. The organization's forecast center specifically flagged the period from July through September as carrying above-normal typhoon risk, extending from the Nansei Islands north through western and eastern Japan, a forecast that was already proving accurate as Bobby's remnants approached the region in real time. The mechanism behind all of this is not complicated, even if the storms themselves are. A tropical cyclone is, at its core, a heat engine. It pulls warm, moist air up from the ocean surface into towering columns of thunderstorms wrapped around a central eye, and it releases the energy stored in that warm water as the moisture rises and condenses. The warmer the water beneath a storm, and the deeper that warmth extends below the surface, the more fuel is available for the storm to draw on. June 2026 was recorded as the second warmest June globally on record by the Copernicus Climate Change Service, with the global average surface temperature that month measured at 1.39 degrees Celsius above pre-industrial levels. That is not a coincidence, sitting next to Baby's rapid intensification. It is the backdrop that made it possible. Rapid intensification itself is defined by meteorologists as an increase in maximum sustained winds of at least 35 miles per hour within a 24-hour period. Bavi blew past that threshold by a wide margin, and it is far from the only storm to have done so in recent years. Scientists studying the broader trend have found that the overall global count of tropical cyclones has not changed dramatically compared to historical records, but the proportion of storms reaching Category 4 and Category 5 intensity has been climbing, and those storms are increasingly reaching peak intensity faster and holding it longer than historical patterns would predict. It helps to put some of these numbers into context most people never think about, because phrases like Category 5 and Super Typhoon get repeated so often in headlines that they start to lose their weight. Hurricane force winds, the threshold at which a storm is even capable of causing structural damage, are defined as sustained winds of 74 miles an hour or higher. A Category 5 storm on the Saffir-Simpson scale requires sustained winds of at least 157 miles an hour. Bavi, at its peak, was carrying sustained winds estimated between 166 and 180 miles an hour, comfortably past that threshold. And, according to some model guidance, closing in on the intensity of the strongest tropical cyclone ever recorded on the planet, Typhoon Tip, in 1979, which reached a central pressure of 870 millibars. Sinlaku in April had bottomed out near 905 millibars. Bavi, at its lowest measured pressure, was estimated near 919 millibars, placing both storms within the same tier of historically extreme tropical cyclones that scientists specifically track and compare against the handful of strongest storms ever observed by satellite. The eye itself, at peak strength, was measured at roughly 21 miles across, sharply defined and symmetric, the kind of textbook structure meteorologists look for as visual confirmation that a storm has reached its maximum potential intensity for the environment it is moving through. None of this happened in a vacuum, and the scientists who spend their careers studying this basin have been explicit that storms like Bavi and Sinlaku forming back-to-back months apart, hitting the same small population of islands, is not simply bad luck repeating itself. It is what the current combination of record or near-record ocean, warmth, and a strengthening El Niño produces when it lines up over the open water east of the Philippines, an area with thousands of miles of uninterrupted warm ocean for a developing storm to feed on before it ever has to cross land or encounter the cooler, more disruptive conditions further north and west. Every one of the specific ingredients scientists point to, sea surface temperature, wind shear, atmospheric moisture, and upper level outflow, is monitored continuously by satellite and fed directly into the same forecasting models that gave Guam and the Northern Marianas several days of lead time before Bavi's eye wall arrived. That lead time is the single biggest difference between the outcome the islands actually experienced and the outcome that was genuinely possible given the storm's strength. It is also the reason meteorologists keep stressing, publicly and repeatedly, that the story of a storm like Bavi is not just about the wind speed record it did or did not set. It is about whether the warning system built to track it keeps working, as these storms keep forming faster and reaching higher intensities than the historical baseline predicted. Gives emergency managers 5 or 6 days of steadily escalating urgency to move people into shelters and secure critical infrastructure. A storm that goes from a 60-mile-an-hour tropical storm to a 166-mile-an-hour Category 5 equivalent system in roughly 48 hours, while still hundreds of miles from land, compresses that entire preparation window dramatically. In Bavi's eye case, the forecasting system worked. The JTWC flagged the disturbance nearly a week before it became a named storm. Advisories were issued days ahead of landfall. Emergency officials across Guam and the Northern Marianas had enough lead time to open shelters, suspend port operations, and issue clear, urgent public guidance. And Andersen Air Force Base, one of the most significant American military installations anywhere in the Pacific, asked all non-essential personnel to stay off base well ahead of the storm's arrival. The zero fatality outcome on Guam and the Northern Marianas was not luck. It was the direct result of forecasters catching a rapidly intensifying storm early enough, and communities that have unfortunately weathered enough typhoons over the years to take every warning seriously the moment it is issued. But the honest, complete picture of Bavi includes what happened after it left American soil, and that part of the story is not a success story in the same way. 17 confirmed deaths and more than 500,000 people affected across the Philippines from the enhanced monsoon rains it helped drive. Landslides burying homes in Sarangani and Lanao del Sur. 87 injuries and thousands of individual disaster reports across Taiwan, a region across southern Japan and coastal China bracing for additional rainfall and wind impacts as the system's remnants continued their slow westward push. A single storm, born from an unremarkable cluster of thunderstorms east of Kwajalein in the final days of June, ended up touching the lives of people across 5 separate countries and territories over the span of less than 2 weeks. And it was, by nearly every measure meteorologists use, one of the strongest tropical cyclones to form anywhere on Earth in 2026, following directly on the heels of Sinlaku, which held that same title just months earlier. Category 4 and Category 5 intensity, and the speed at which they are getting there, is measurable, tracked, and published by the same agencies that issued the advisories on Bavi from its earliest days as an unnamed disturbance. What those scientists keep repeating, in interview after interview and report after report, is not a prediction that the sky is falling. It is a far more practical and far more urgent point. Storms are intensifying faster than they used to, which means the margin of time communities have to prepare is shrinking, even as the forecasting technology tracking them gets better every single year. The lesson from Bavi, and from Sinlaku before it, and from every storm still forming across an unusually active Western Pacific season that has months left to run, is the same lesson repeated by every meteorologist who has studied this basin for a career. Take the warnings seriously the moment they are issued. Move to shelter before conditions deteriorate, not after. And do not assume that because a storm is thousands of miles away and forming as a disorganized cluster of thunderstorms today, it will still look that way in 48 hours. Bavi did not. Sinlaku did not before it. And the Western Pacific typhoon season, according to every scientist watching it, is not close to finished. If you want real-time coverage the moment the next system starts organizing, subscribe and turn on notifications, because these storms do not wait, and neither should the people in their path. Share this with anyone you know across the Pacific, the Philippines, Taiwan, or coastal Asia. And if you're currently under any typhoon watch or warning, act on the guidance from your local emergency services right now, not after the winds arrive.